All right, so this is kind of maybe like a continuation from last year. I know a lot of people have seen me talking about blockchain a lot recently. It's something I'm very passionate about. Yeah, it sounds good, yeah. And something I'm very passionate about, and I think it's the future of a lot of different things. And what I do is I'm going to take a very practical approach on this. I'm going to talk about blockchain a little bit, and I'm also going to talk about some of the use cases that I think are the future of this thing. And I'm going to go through some code and show y'all how. I'm going to show you a little bit of JavaScript code. JavaScript is kind of like the predominant language in blockchain and Ethereum development and all that stuff on the front end. And I'm going to show some Solidity, which is Solidity is the language, kind of like the official language for Ethereum. So I'm going to go through this and hopefully we have some fun. Hopefully you learned a thing or two. Hopefully I learned something because I'm pretty sure I'm going to get good feedback from y'all. All right, cool. So next slide. Okay, cool. So this is actually on the talk description. I think that I'm very passionate about thinking cybersecurity professionals need to do this because all the companies that we work for are eventually going to be using blockchain technology. You're probably going to be taking some kind of crypto payments. Right now, predominantly Ethereum-based tokens are the predominant form of transfer. There's this coin called USDC, which is used for a lot of different transactions across the world. Ethereum is the number 2 crypto behind Bitcoin, but from a practical usage standpoint, the Ethereum blockchain is kind of like where it's at, and there's a lot of side chains. So this talk is going to cover what they call Ethereum virtual machine (EVM) environments, and there's several blockchains that have our EVM environments. All right, so we're going to talk about I'm going to talk about smart contracts. I'm going to talk about developing smart contract stuff. Again, a little bit of code. I'm going to talk about Web3. Web3 is kind of a marketing term used for all this stuff. It's been used in relation to NFTs. NFTs were booming last year. Now NFTs kind of are in the dumpster fire. But this whole space is moving super fast, and I think the core technology is what I'm focusing on here. And the core technology is going to be around for a long time, and I think it's going to change the way we do stuff in our regular security labs. All right, cool. And we're going to explore common issues. There's 3 issues that I'm going to cover at the end, and I'm going to give you resources to go find more. So how many people here have developed a smart contract before? Cool. A couple of people? Sweet. You over there doing a smart contract right now? What's the plan? Okay, fantastic. All right, cool. So Ethereum is what we're talking about here, but what we're talking about mostly is the Ethereum virtual machine. So Ethereum virtual machine, what that means is that all these Ethereum, what some people call them miners or whatever, some people call them validators. What many of those things are doing is they're running this code that we're running in Solidity. It's compiled, and they're running this code on their miners, and the miners get paid for running the transactions. The big technology name, people call it a blockchain, but the real name is distributed ledger technology. I think the more the correct terms you use, the more information you find. Because when I first started out, I've been heavy into this for like the last year, and this is totally on the side, not a part of my day job. I do develop a lot of apps for my day job, but at night I like to play with blockchain. So Ethereum EVM is what we're talking about. Ethereum virtual machine. Ethereum virtual machine essentially means any node that runs this code for us. That make sense? All right, cool. So why? Again, there's tons of applications that I think that blockchain has done. So far, we have coins and people speculating on coins. There's been NFTs that blew up, like I said, last year. And I think that sometimes there's unintended consequences or unintended benefits, even when you talk about blockchain. And I think that I'm going to talk about some. I think it's going to change a couple of things like authentication. I think it's going to change a lot of different things, and I'll show you on a little bit why this is. So wallets. First thing, how many of y'all have a wallet, a crypto wallet? Okay, so that's a lot of people. How many people have done transactions on Ethereum blockchain? A couple people. How many people have done Bitcoin? All right, cool. So we got some crypto heads in here. So what an externally owned account is it's a public-private key pair, essentially. And what that allows you to do is to make transactions on the blockchain. So a wallet is an externally owned account. Now, the cool thing about Ethereum that a lot of people don't know, there's no transactions that run unless there's an externally owned wallet paying what they call a gas fee. And a lot of people complain about gas fees, but what gas fees do is it prevents denial of service attacks on the blockchain. Because you can only have so much Ethereum in your wallet, and you would have to spend, they basically have gas caps on how much operations that a Ethereum virtual machine could do. Other than that, somebody would have some kind of stupid program that they ran, and it would run out forever and would lock up the entire blockchain eventually. You could DDoS the blockchain by creating some crappy program that does an infinite loop or something stupid like that. So there's a gas thing. So after every time something runs an operation, so every time it adds, subtracts, changes the variable, there's a gas fee associated with that, and there's a gas cap. Eventually, if you run out of gas, the program stops. So a lot of people can write bad programs, but what's cool about it is that this Ethereum virtual machine is kind of like a lot of people, there's actually a protocol called ICP, which stands for Internet Computer Protocol. That's a different blockchain, but the idea of having an internet computer is blockchain. Of course, many of y'all know that the people came up, some of the hardcore purists on blockchain, what they want to eliminate the banks. And so what the distributed ledger does, it has all these nodes all over the place, and they're keeping it instead of a central bank keeping it. So it's distributed so we can do financial transactions. But what's cool, Bitcoin did that and totally crushed it. There's a couple more for Bitcoin, but then Ethereum came out with this thing that you can actually run code, and you can run a little bit of code on related to Bitcoin scripting, but Ethereum is really something that you can code on, and it's really awesome. And I'll show y'all how this does. But the first thing is an externally owned account pays the gas fees and can initiate transactions. So that's why a wallet's important. It's a public and private key. And just like in cryptography, in traditional cryptography, the private key is held private. And what you can do is sign transactions and prove that you own the account, prove that you own the ether, and all that stuff. So this is actually pretty cool. Funny enough, my background is I was in the US Navy. I joined in 1993. I think I'm getting old as a mug, but I did cryptography in the Navy. And one of the biggest breakthroughs in cryptography was public-private key in cryptography. People familiar with Diffie-Hellman and all those different them OGs of the space. This is pretty cool because when I first heard of blockchain, I heard people talking about cryptocurrency. I did not understand that it was actually related to something I've been doing since I was 18 years old. And I was like, God dang it, I can't believe I've been in this space for all these years. I actually have a crypto patent for communications as well. So I'm a patented cryptographer, but I totally ignored the cryptocurrency space until last year. It's the craziest thing. I didn't realize that there was that applicable knowledge that I already had. But then I picked it up, I was like, God dang, I've been doing this since I was 18 years old. All right, so how do wallets work? I talked about the public key, the private key. Private keys used to sign transactions, just like regular old crypto. This is stuff we've been doing in the security space for a while. We've been talking about PKI, signing stuff. This is the same exact stuff. It blew my mind. I was like, wow, we've been doing this for years. There was a couple different things. There's this thing called a hot wallet and a cold wallet, right? A hot wallet is something that resides in your browser, and the difference, and it resides in your browser, that means your browser is caching the private key. So in your Google storage thing, in your Chrome or whatever browser you like, it's actually saving this private key inside the browser. That means if your machine is compromised and they can access that, then they can get your private key and sign transactions on your behalf. And that's why that's a hot key. It's hot, it's live, the key is accessible from anywhere. And then there's a cold wallet. The cold wallet, what happens with that is actually brought one if you want to see one. Many times they look like a little USB device. The difference between that is that your computer can't access, quote unquote, can't access. And this is you'll see a lot of challenges on hacking wallets because you have to jump from the machine to the USB type devices. And there's a couple of different USB devices. The reason it's called a cold wallet is that your machine typically does not have access to the private key on it. So you can sign transactions with this USB device. It's kind of like a YubiKey or something like that we've been using for years as well. That's what a cold wallet is. And it's highly recommended if you have a lot of crypto assets that you use a cold wallet. You can take that cold wallet and you can plug it into any machine you want. And technically, they're hardened against extracting that private key. That's why it's important. MetaMask is the most popular hot wallet. How many people use MetaMask? A couple people. Yeah, so MetaMask is the dominant player because they have ties to the actual Ethereum core team. So there's a recurring theme. These guys are smart, by the way. The guy that created it, his name is Vitalik Buterin. He's super smart, and he has a whole core team. And these guys are eating. They own OpenSea. They created MetaMask. They making so much money off Ethereum. It's ridiculous. And I think Vitalik's a billionaire. All right. So what we need to know from an AppSec perspective, right? AppSec. There's these two main libraries, and so Web3 is there's a thing called Web3.js, right? And Web3.js is pretty interesting because it actually there's a Web3.js for multiple blockchains, right? Ethers is pretty cool. That's my favorite library that I choose to interact with. I use Ethers. Ethers allows you to use JavaScript to communicate to the blockchain. Now, you cannot, I don't have a slide that says this. This is kind of cool too. You cannot communicate directly from your machine to the blockchain. You have to use an RPC provider to do that. And what MetaMask does is it gives you a RPC provider for you. Now, MetaMask is this website called Infura, I-N-F-U-R-A. Infura is the predominant RPC proxy. So to interact with the blockchain, you either have to have a node yourself. A node, I think it costs over 30 Ethereum to do, and that's a lot of money, huh? 32, something like that. You need to have 32 Ethereum to actually be on the blockchain, and you have to lock it up and stake it, because what happens is if you do any shenanigans, they'll take that 32. It's a punishment. So you pay for a node, and if you do anything crazy, what they call front-running transactions, where you're trying to profit, you're trying to do all kind of shady stuff, they will take all your ether and your node will be kicked off the blockchain. So these guys have thought about a lot of security and a lot of different things. And the reason why I'm saying that is because most of the time if you're dealing with MetaMask or something like that, you're actually communicating to an RPC proxy that Infura owns, and Infura is doing the blockchain transaction on your behalf. But you're signing it with your private key, right? Y'all got that? Cool. So the way to communicate to the blockchain is you're using Web3, you're using a private key in your externally owned account, your MetaMask or your hot wallet. And what you're doing there is you're interacting with a proxy somewhere. And the MetaMask actually uses Infura too, by the way. We found this out because there was like a trade sanction, some kind of new rule, FTC regulation that actually blocked Russia and Iran and all that stuff. And Infura, everybody that was trying to transact from over those countries got blocked overnight. And everybody had their crypto locked up. It was kind of crazy. Everybody's panicking. All right, cool. So basically this is basic actually, I kind of redesigned my slides at the last point. Hopefully y'all can see this a wee bit. Basically you have a staking contract and you just need the address of that contract. And right here you have this thing called an ABI. The ABI stands for, I think, application byte interface or bytecode interface or something like that. It's ABI. You can look up what the real meaning. I'm from Texas. We don't read well anyway, so. So what you do is you have the contract address. Anytime you publish a contract to the blockchain, it has a address. It starts with 0x something. It's a long hexadecimal address. But to interact with it, you need the API. The API is kind of like an API. It tells all the functions, all the things that are related to the blockchain. And you have to have a signer. The signer is your private key, essentially, in other words, right? And to interact with this, if it say this is a staking contract and I wanted to stake Ether to this contract, what I would do is I would say stake. I would initiate the contract, right? And then I can just pass that and I say stake. And Ethereum and most stuff on Ethereum is 18 digits, right? That's 18 digits, which is a long number. So what you have to do is sometimes you take you parse it and all that stuff. And right here it's asking for a term, because there's always a staking term. You can stake it for, usually you can stake it for a year, you can stake it for 30 days, or whatever. But basically that's how you would interact with a contract. Now, what's interesting about this is eventually when y'all start doing assessments on these contracts, not even a contract, with the web app piece, you should start understanding how you interact with the blockchain. Because surely this is gonna come up. Everybody's doing Web3 still, even though NFTs died down. I'm confident that y'all are gonna start having an understanding what this stuff is about. You can actually create a wallet programmatically too with Ethers. You don't have to, and so this is actually used for a couple of different reasons. And up here you see I'm saying, hey, cool, this is library called Ethers. This is JavaScript, and I want to create a random wallet, and now the wallet is my wallet. Now, the reason why you would do this is because on the back end, sometimes you might want to do transactions on the back end on the server. And so you need a wallet on the server, right? And so that wallet is essentially going to be a hot wallet. And how you do it, you create that wallet ID, you create this wallet, and it's going to return your public key, your private key, and it's going to return a seed phrase for sure. A seed phrase is a mnemonic. A mnemonic is like a passphrase. It's usually 14 words, 12 words. It's something like that. But anyway, so what that does is that allows you to restore that. So if you're doing a blockchain application, so you know how many applications, I'm talking about traditional applications, you have you're going to have environment variables, right? And so what you would do is you would put your mnemonic or something like that in the environment variable. So when the app boots up, it has access to the wallet. There's plenty of use cases where you need to have a private key on the server, but this is super important. If that private key, I would say, if it's used to do financial transactions, it's super important to keep that private key in that server super secure. That's the main way somebody can get popped, is if that private key is doing financial transactions, and there's some cases where you have to have that, you need to make sure that it's good to go, right? And you can even rotate these keys. This is why it's super handy to do this. I'm going to talk about a little bit of permissions and stuff in a little bit, but it's important to be able to create a wallet to do proxy transactions, is what I call it. That makes sense? We good? Hey, and y'all can stop me at any point and ask questions. So, any questions so far? Go ahead.
You said that the private key in the server must be kept super secure.
Yep.
What are your recommendations for keeping it super secure?
Yeah, so never put it on GitHub. Don't put it on OpenD. All the regular stuff that we have when we keep passwords secure, same apply. Keep it in an environment variable, put it in a safe, or whatever the best thing that you have to keep that secure. And also, like I said, what's cool about this is you can rotate these. These are completely random, very low chance of any kind of collision happening. And I say, like, astronomically, it's like we get struck by lightning 2 times when we walk out this building for the collision happens. So you can create a random, this is secure. You can create a random key phrase, key pair, and it'll be secure. All right, Solidity. Solidity is the programming language for Ethereum blockchain. There's a couple of more different programming languages, but essentially what happens is this gets compiled down to web assembly, essentially. So when it's compiled, it's compiled to WebAssembly, and that's what runs on the node. Okay. So the truth is, you can actually, anything that compiles down to WebAssembly can pretty much be used. So there, on other blockchains, there's a couple of different programming languages used. Solidity was created by the Ethereum team. There was a big hack several years ago. It's pretty solid now, but it was a big hack back in the day that caused a split between Ethereum, and then there's like a new Ethereum chain that Vitalik and his team is still running. But there's Ethereum Classic, which is the old version that got hacked big time. All right, so this is something you got to get familiar with too. If you're talking about doing Solidity development, it's called Open Zeppelin. These people, this company, I'm pretty sure they're funded. They're really smart people. What they do is they make a lot of dependencies, I would say, so that you can import into your Solidity contracts now. And some of these are really cool. They have like there's an ownable one. Ownable means that you can actually set up who owns it automatically. So if you deploy a contract, you own the contract. So by default, a contract has no owner. I'm going to show you that in a little bit. And this is where some people run afoul. It's just like if it has money on it, it has no rules on who can withdraw the money. There's people out there scanning for those kind of contracts. So there's also a reentrancy attack. A reentrancy attack is a big attack. I'm going to go over that, and I'm going to hopefully get a demo, show you all a demo for that in a little bit. What a reentrancy attack is you exploit a contract by doing a transaction multiple times before it can do anything else. You can essentially create an attack, and I'll show you all this attack, and it can totally drain all the Ethereum out of a contract. And that happens a lot, by the way. We see that a lot. Anytime you see these big heists, there is some kind of vulnerability where they can exploit the smart contract. We're going to be using this. This says Remix IDE. What's beautiful about blockchain is that there are so many tools available now, and you can write smart contracts and deploy them from this Remix IDE. Remix IDE. It's also another thing created by the Ethereum team. I'm going to show you how to use that in a little bit. This is the easiest way to learn blockchain. I wish somebody would have told me all this stuff a year ago. So like, I've been through the ringer, and I've learned all this stuff, and I bring it back to my people. All right, so this is a basic contract here. This contract does nothing, of course. It's ... You can put whatever you want in there, right? So the thing up top is kind of like the licensing. Then you tell it the minimum version here of this. This looks like a lot of other languages. That's a basic contract. And in that contract, you can do all kind of cool stuff. Dang, this is hard to read. Sorry about that. So this is a Solidity event, and I can share the slides with whoever. Y'all can just hit me up. I'll try to share the slides and make sure the team gets it. But this is a terrible. This says event. So the reason why events are important is because events allow you to write things to the blockchain. So a Solidity event allows you to write information. That information can be the amount of a transfer, the address that it did. You can put strings in there, like, for instance, a great use case. There was this thing called the poor man's copyright back in the day. And what a poor man's copyright was is you mailed a letter back to yourself. Well, what's interesting is I wouldn't be surprised you can actually do a hash of a file and then do an event on blockchain, and you can write that hash on blockchain to prove that you wrote it to the blockchain on that date. So there's all kind of interesting things, like that could be a product. I mean, I haven't built that or made it, but that could definitely be a thing. But if you think about security logs and litigation and things of that nature, is how cool is it now that what we can do from a chain of custody perspective to be able to create events on a blockchain where it's kind of like it's international, worldwide, and there's no fudging around with it, because traditionally when you do incident response, you're going to hash all the evidence. Well, then you can hash all the evidence, and you can actually write an event onto blockchain with references to that hash. That's pretty cool. So this is how you would write data to the blockchain through Solidity events. All right, there's also modifiers. These are actually important because a modifier allows you to build rules related to executing functions. In this case right here, So anytime anytime you do a transaction with a smart contract, that's a message that you send to the smart contract. Now, message.sender is the person who's sending the message every time. So every time you interact with a blockchain contract, message.sender is going to be your address. Now, owner in this case, and I'm going to show you how this works in a little bit. The owner of the account is created typically when the contract is created, right? Now you can use Open Zeppelin has this ownable library that you can use to import it, or you can just write it yourself. And I'm going to write it myself in a little bit when I get to the demo part. I'm going to do a live demo. I know I'm tempting the gods of conferences and all that stuff, but I sacrificed 2 goats before I came here. All right, so this right here, token gating, is huge in the NFT community. This is one of the best things that I think that we can take from the NFT communities. So basically, if I buy NFT, if I buy Bored Ape, whatever and there's all kind of NFTs out there. What you can do is you can use that token contract. So NFT stands for non-fungible token, right? So that contract is a contract that has everybody that owns the token. So it would have my public address if I own the token on their contract. So what you can do here is you can actually write JavaScript, and this can be front end or back end JavaScript. This is using Ethers. And you can say, hey, this is signer again is essentially your wallet and a provider. A provider is an RPC provider, right? As I said earlier, Infura is the most popular one. Now I want to connect to this contract. This contract will have an address up here, as we showed before. The address here is the address of my public address. So now I can do that call to Bored Apes, and it will tell me, hey, yeah, he owns ape number 23. Marcus owns that. So now what I can do is I can give authentication to an application now. Now this is actually great, by the way. Not talking about NFTs, but imagine if everybody in your organization, you could actually give them an NFT to log into a web app. That's freaking amazing, by the way. That could be like the new Duo or something like that. And like I said, there's always unintended consequences for technology. And to me, like, wow, they did this to like give their NFTs utility, but dang, I would really like this, because what happens is you can actually, from a contract perspective, if that key got compromised, you could get rid of you could just cancel that NFT. So now we can create something like an NFT for corporate, and I guarantee you this is going to happen. I just, in my gut, I think this is going to happen, because public key infrastructure and asynchronous cryptography, this has always been a pain point. Now you're telling me now I can download a browser extension, right? And now and you can issue me a token, and now I can do authentication to that. That's a freaking IT dream to me, in my opinion. Voter registration, all kind of stuff. Oh, so I take it even further. Voter registration. Think about getting tickets like a Ticketmaster compromises bootleg. So all of these different things you're going to be able to do with this same technology. Even though we got, a lot of people got hot and bothered making money off NFTs, this is cryptography, people. And so there's all kind of things that we can do with the cryptography that we didn't expect. Again, you deploy the contract, and you would do some kind of registration of everybody in your organization. Here's their private key. Here's their public key. You say the private key remains on the machine, and they can authenticate to any application you want to. We're going to see that happen. Somebody, if anybody here invents this technology, throw your boys some pennies. Hard hat. I love this logo. It's a hard hat with an Ethereum logo on it. Okay, any questions so far? Good. I must be doing an amazing job or a terrible job. All right, so hard hat. Hard hat is super important. Check this out, hard hat. Look up hard hat Ethereum, because what you can do is you can replicate a blockchain. This is your own private blockchain on your own computer, right? So if you're doing smart contracts, you can actually deploy these smart contracts to your local machine, and you can do all your testing. And you can do automated testing too, by the way, like traditional JavaScript testing, where you do you describe the test and then you try to do stuff. You can do this for somebody's going to invent this, probably somebody in this room, hopefully. You're going to be able to, with hard hat, what you can do is you can actually forward time. So say if you have a time lock contract, right? If you said, hey, I'm going to lock my ether in this contract for a year, you can actually test that out in hard hat. And you're on your local environment. You can deploy it to the local environment. And then what you can do is you can deploy the fake ether. It comes with fake ether on hard hat. You get all these accounts. And what you can do is you can forward time on hard hat. You can't do it on the regular blockchain. So if you deployed something without testing on a regular blockchain and you thought it was going to be 3 years, you could have accidentally put it in for 3 seconds and then people grab all your crypto. So what's cool about this is any scenario that you think that can be from a contract related perspective, hard hat's going to let you do this. Why is this important? OWASP, you're going to be doing this. Somebody's going to give you a smart contract and you're going to like, how do I test this? Right? This is it right here. Now, I'm pretty sure that somebody's going to, there's so many different kind of apps. There's some standard apps, like a NFT contract is pretty standard. But people that's writing these DeFi protocols and all these different things, you can actually, so first of all, I would ask them, hey, you created this DeFi thing. Did you create any kind of test? Did you do any automated tests? And if they did, it's probably going to be in this. Grab the automated test. And then what you can do is you can actually use their test, and then you can augment their test as well. Go ahead. Yeah, so there's a couple of different things. At RFC, there's EIPs, Ethereum Improvement Proposals. EIPs is what you want to look up. So there's RFCs, back old school guys. You know what I'm saying? He said, to look up specs, go there. Also to look up to look up really good implementations of the specs. For instance, NFT, there's a spec. It's called ERC 721. So an EIP is the proposal, and an ERC is the actual implementation of the. Yeah. ERC 20 is a typical token. So USDC is a very popular token, and that's actually using. That was an EIP, and then the EIP becomes ERC, which is an official standard. And also, what's cool about the Open Zeppelin thing that I showed y'all earlier, it implements really good, solid implementations of the dang ERC 20 or whatever. It has all those things that they implement. So check out Open Zeppelin again. But hard hat, this is freaking awesome because what you can do, test. And y'all can make a lot of money off testing these contracts, right? It's crazy. People are paying a lot of money for this. How many people use Next.js in here? Has anybody used Next.js? All right, this is the absolute future of, I believe, somewhat DevOps, by the way. I believe that this is gonna replace a lot of DevOps type stuff, right? A lot of stuff you do in your normal DevOps job, if you do DevSecOps or something like that, Next.js is pretty awesome. So the reason why this is relevant is because most of the blockchain apps are writing their stuff in Next now. Next.js, as you see here, is React.js plus Express. So traditionally what you see in most applications is you see people writing applications in React for the front end. And then what they do is they write Express. So there's typically like, even if it's in one library, it's like 2 distinct code bases. When you're doing your from a JavaScript perspective, when you're doing your whole npm yarn and all that stuff, you're doing it to 2 separate instances, right? What's interesting about Next is it combines everything into one experience. So you can write front end and back end code in the same repo and with the same packaging and all that stuff. So it's cool for a couple of reasons. What's really cool about it is this thing called Versal. So Versal is the team that made Next.js, right? You're going to see, if you're testing apps, you're going to see this in your near future because this is killing it on the internet. And the reason why it's killing it is because You write your code in Next.js, and the only thing I have to do is I just have to put my repo. I just have to, put my stuff in a repo, like a GitHub or something. And then after that, what I do is I just go to Versal and say, hey, here's my app, and it does everything for you. Only thing you have to do is put environment variables in there. All the deployment that we've been doing in traditional DevOps and all that stuff, how we do a Kubernetes and this and that. Now, this right here is serverless. You create it, and it does front end and back end. Next.js is super powerful because it allows you to write your API in one folder, in one directory, and it just works. And all your environment variables, it understands the difference between public environment variables and secret environment variables off the rip. So this is a groundbreaking technology that a lot of developers are using, and some big companies are even getting on board. Another thing that's cool about this is in traditional React app, what people were doing is they write an app and they use something like React Router. And what React Router does is it does fake routing. Fake routing in the sense that there's not another page and all that stuff. Well, what's cool about Next.js and Versal is what it allows you to do is it allows you to, it has real routes, and it has real API routes, the whole nine. It is groundbreaking. So if you're trying to create a product, or if you're looking for something, if you don't have a DevOps team, it could be good for any company to do. I'm writing a lot of apps in Next.js myself. All right, cool. So we're almost to the demo part here. So roles and permissions. Like I said, by default, a blockchain application has no roles or permissions. You see, I said contract, open and close, and that's it. That's the smart contract. So remember this, roles and permissions. There's no roles and permissions unless we build into the contract. Well, it says demo time. Kind of reminds me of hammer time. But I promise I will not be dancing up here on stage. I think that slide was misplaced, but I'm gonna talk about a couple more things, and then I'm gonna demo it hopefully live. So frozen assets, this happens. There's contracts out there on the blockchain that have millions of dollars in Ethereum locked into them. Could you imagine if you deployed a smart contract, it made millions of dollars, and you couldn't get the money out of it? I'm gonna show you how that happens. And this is this is the least thing you could do if you're looking at contracts. Just make sure they can get their money out. This happens, and it's easy to do. And there's several examples of millions of Ether out there that cannot be collected by the person who wrote the contract. If I was that person, I'd be pissed. This reentry attack here, if you take a picture, you can actually take a picture of this and maybe type the whole thing out. But it's this really thing called soliditybyexample.org, and they have all kinds of different hacks. So the reentry attack that I'm going to actually display, I got code from them, and I'm going to just show you because it's a really good explanation. And watch that YouTube video because they're going to explain it way better than I can. Okay, cool. So what I'm going to try to do here is go to remix. All right, so that's tiny, but I'm going to try to blow it up for y'all. I think I can do it right here. Okay, cool. So in here, what you can do is you can have different folders and you can have your contracts in here. The first contract I'm going to show is this one right here. I commented some stuff out because I wanted to show you that you can deposit Ether into an account, and I'm going to show you the thing that you can't get it out. And then we're going to add this withdraw function right after that, and we're going to show that you can withdraw the Ether. 5 minutes? You got 5 minutes? God dang, can I do this in 5 minutes? Yeah. Let's go. All right, so I have no contracts deployed. And what's cool about this thing right here is that you can actually, different virtual machines, this London, Berlin, all that. So I'm going to use this Ethereum VM, and I'm going to deploy the contract to it. So this says withdraw. I'm going to deploy this contract. Every contract has an address. You can copy that address. Remember I said it's hex 0x right here. And so what's interesting about this is that on these virtual machines, you have fake Ethereum. I have fake Ether. Ether is the currency. Ethereum is the network. So fake, I have 90, it starts with 100 fake ETH, but it costs me gas to deploy this contract. So what I'm going to do up here is I can put a value. I'm going to put 10 ETH in here. Oh, it's 100 ETH. Oh, we'll do one. Be frugal. It's fake, so who cares, right? So I'm going to deposit this, right? And when I deposit it, you're going to see the balance of this contract is 1 ETH. Now it's showing me this. This is just a helper here. It says balance 1. But when I say balance, it shows me the balance, but there is no withdrawal function to this contract. That money is locked in this contract forever, and there's nothing you can do about it. That would suck, wouldn't it? You never want to audit a contract and give it back to them without the withdrawal function. So what I'm gonna do is I'm gonna delete this. I'm gonna just, that contract, once it's written to the blockchain, it's there forever. There is a self-destruct function for contracts. I'm gonna give you a book that you can read in a little bit. It's called Mastering Ethereum. I have a reference to it. But what you can do there, what we're gonna do real quick though, is we're gonna uncomment this function, right? And now this automatically saves in here. We're gonna deploy it again. So right now, I'm gonna say deploy. And what we have there is we have a withdrawal function now. So I can deposit ETH. Oh, I didn't deposit anything because I didn't have no value here. So I'm gonna deposit 5 ETH. And I'm going to deposit it. And now you see the ETH is in the contract. The balance is in the contract. And now since I added a withdrawal function, I can withdraw and it's 0 ETH now. That's how you get paid on Ethereum. So that's super important that's like one of the most important things you could do is do that for your customers or whoever you're consulting for or your company. All right, cool. Next thing I'm gonna try to do, and I got like 3 minutes to show it. This is a very popular attack called a reentrancy attack. And I gotta go in here. This is the code. Remember this code? You can get this code from that link that I showed you earlier. You can go get this code and play around with yourself. You just have to go to remix.ethereum.org and play around with this stuff. All right, so in here, I'm gonna go back over here. And what's cool about this is I put 2 contracts. You see, contract, I put them in the same file. You can do that, right? So now what I'm going to do here is this Ether store. This Ether store is a contract that I'm putting money into. This is a typical scenario. People pull money, do all kind of crazy DeFi schemes on here. So the first one I'm going to do is, okay. So I'm going to deploy my Ether store. The Ether store contract is just going to hold crypto and give it back to me. So I'm going to deploy it. I got it down here. And what's cool is I can deposit money into this Ether store contract. What I'm going to do here is I'm going to take money from several different accounts, and I'm going to deposit money in here from several different accounts. So I put money in. I should only be able to draw my account or any interest that I earn. That's the whole deal, right? It's storing it, and hopefully I earn interest. That's what most of these things do. So I'm going to do 2. I'm going to just put 1 in here, deploy, and I'm going to go to another account. So these are all externally owned accounts. These are all fake wallets. Don't ever put any real money in the fake wallets because people scam them to steal that money all the time. This is actually a valid. You've done that?
No, I had a question.
Go ahead.
So the Ethereum balance on the contract is separate from the balances variable that you call like in this thing, correct?
Yeah. So basically, anytime so these up here are the externally owned accounts. They have Ether on them, and you can send that Ether to a contract.
Yeah, but like in the previous example, you had a variable called balance at the top, but you didn't really need that because the contract has the balance built in.
Yeah, but you can't see it unless you have a function. So if you have a public function, you can call it to get the balance.
Okay, cool. Thank you.
Oh, what the heck am I doing? I'm stupid. I'm deploying. That's what I did. Let me try to get this working. All right, cool. So I deployed 3 ETH in here. And what I need to do is I need to copy this address because I'm going to do this attack contract real quick. So what this attack contract is going to do is before it deducts the amount that I put into the contract, it's going to let me pull out all the money out of the contract by putting 1 ETH in. That's the whole thing about this contract. So I'm going to put in this address. This address is a reference to the other contract. So I'm going to deploy this one. And I can go to a complete random contract. I'm going to go to a complete random with 100 Ether in it, just to show. So it's 100 Ether. And now what I can do now is I can do one attack. So what it's going to do is going to deploy 1 Ether, and it's going to drain all the other Ether out of that contract. So I have 3 Ether in here. I'm deploying 1, and I'm going to get all the Ether back. Now my balance is 4. See that? So I put 1 in, and I took everybody else's money out. And the reason why this attack is allowed to happen is because here at the end, I set the balance to 0. What you have to do is before you do it, you have to move this up to the top, and that would actually mitigate that attack. You set the balance to 0 because the next time they come into it, they can't get anything else out. So what happened is, before the contract kept on hitting it to withdraw before it set it to 0. Anyway, thank you very much for listening. Is there time for questions or anything, or am I done? Am I worn out my welcome? So anyway, check this book out. The book is called Mastering Ethereum. You check it out. It's a really good read. It kind of explains the philosophy and a lot of the things I even mentioned. This is the Smart Contract program on YouTube. This guy is awesome. So I recommend building. I've always told people, if you want to get into hacking stuff, build, right? That's my philosophy. If you want to get into hacking, blockchain, hacking Ethereum, start building. Any questions? We good? Thank you very much.